Okay, now listen to me. The question is, do normals are always equal? यही है ना क्वेश्चन तेरा. This one is also n, this one is also n. In the previous example, what we have taken one example like this. One sphere is being placed like this over here. Even though we have taken this normal and this normal, these values are equal. Yes or no? Do normals are always equal? यही है ना तेरा क्वेश्चन. Okay, सुनो. Normals are always not equal. The values of normals are not equal always. We can say that this is a symmetric system. Yes or no? Similarly, this one is also a symmetric system. If I divide from the center like this, then it will look like a mirror image. Similarly, if I divide from here, from the center, again it look like a mirror image of each other. Then we can say these two are what? Symmetric system. Whenever you will be finding the systems are symmetric, then and then only consider both normals are equal. If system is not symmetric, then definitely you will be finding different normals. ठीक है, आई बात समझ में? क्वेश्चन कर लेंगे क्या उस पे? Okay, someone rub the board fast. Let us draw the asymmetric system so that we can have the different values of normal. Okay, consider here is a sphere like this. Consider here is the sphere and this sphere is being placed like this. And definitely one normal will be passing from here. Or yes or no? Consider this as your n1 and one normal definitely passing through like this. We have to draw a tangent over here, then it will be definitely passing through the center again like this. And you will be finding this as your n2. Or yes or no? Consider this one is having a mass is equals to 10 kg and let's say the radius of this sphere is what? 10 meter. Okay. Similarly, if one more system is being arranged like this, let's say like this. This is one surface, this is the other surface. This surface is making with 30 degree and this surface is making over here with 60 degree. Okay, and given that the mass of this one again is what, let's say 10 kg and radius is also 10 meter. Okay, अभी इसमें angle कितना आएगा देखो. If this one is passing over here, this angle will be 90. Are yes or no? Try this. This one definitely is 90 degree. Are yes or no? Obviously this whole angle is also 90 degree. And we can say this, the tangent and this radius also making an angle 90 degree. Then can I say this one will be having an angle of 45 degree? Are yes or no? So this normal is as it is. Mg is acting in the downward direction. Mg is acting in the downward direction. This component can be resolved into two components, one over here, the other over here. Are yes or no? If this angle is 45 degree, then can I say that over here is also 45 degree? Are yes or no? Then this angle is what? 45 degree. Then N2 over here will be N2 cos 45 degree. एक component इधर जाएगा. This one is N2 cos of 45 degree. And this one will be N2 sin of 45 degree. Are yes or no? So you will be having what different values of normal. Similarly, come to this point. If I want to calculate the value of the normals, इसको solve कर लो आगे. Okay. Then can I say that mg is acting from here in the downward direction? Are yes or no? And if I want to draw one normal over here, this normal will be acting like this in this direction. Let's say this one is value n1 and one more normal may be passing from here like this n2. Are yes or no? So you will be finding what two different normals. इसमें से निकालो इसको. N1 is passing like this. This is your N1 and if I take over here as a triangle, then one triangle is passing like this. Yes, and this whole angle is what? 30 degree, na? This angle is what? 30 degree. This surface 1, and this is your surface 2. For this surface 1, if this is 30, obviously this becomes what, 90 degree. Yes, ऐसा एक लाइन बना लो भाई, ऐसी वाली लाइन. This angle is what, 90 degree. Are yes or no? If this is 90 degree, can I say that this will be 60 degree? If this is 60 degree, then can I resolve this as two components over here and one more here? Yes, if this is 60, obviously this also becomes what, 60 degree. This whole angle is 90 degree, then this becomes what, 30 degree. Then can I say in the upward direction you will be finding what, n1 cos of 30 degree, and this one is what, n1 sine of 30 degree. Okay, similarly over here, can I also draw one more straight line like this? Then again you will be finding one triangle over here. This is the direction of what, n2, and you will be finding one more triangle like this. And now this angle with this surface is 60 degree. Okay, with the whole surface, ये नीचे का surface दिख रहा है ना, इसके साथ ये वाला second surface is making an angle of how much? This is your S2. Okay, so second surface is making with the ground, let's say 60 degree, then this becomes what, 90 degree, then obviously this becomes what, 30 degree. Can I, resolving this into two components, then can I draw like this? Are yes or no? So over here, if this is 30 degree, then stretching this becomes 30 degree. Are yes or no? And we know that these two are making an angle what, 90 degree, then obviously this becomes 60 degree. Are yes or no? Then one component will be going in this direction and other component will be going in this direction. Are yes or no? Solve this and tell me the answer now. Okay, everyone got the answers na? Chalo, ye kitna hai? 60 degree. Then obviously this becomes what, 30 degree. If this is 30 degree, this is n2. So n2 of cos of 30 degree over here, and this one becomes what, n2 sine of 30 degree. Are yes or no? How many forces are acting in the downward direction? देख लो दोनों diagrams में. Then if I want to draw the FBD, then can I say that n1 cos of 30 degree is acting in this direction, and in this direction you will be finding what, n1 sine of 30 degree, and in the downward direction one thing is acting for sure, that is what, mg, and n2 sine of 30 degree is also acting in the downward direction. So n2 sine of 30 degree acting in this direction, and over here who is acting, that is what, n2 cos of 30 degree. क्या तुम लोगों ने ऐसे ही बनाया? Okay, then can I say that by substituting the value, that is what, n1 is 30 degree. Here up कर दो. Okay, so solving this, then can I say that n1 sine of 30 degree, which is equals to n2 cos of 30 degree. This is your equation number 1. Okay, and then can I substitute the value, that is what, n1 n2 1 by 2, which is equals to n2 cos, that is what, root 3 upon 2. Can I cancel this 2 and 2? Then can I say that from here n1 is nothing but n2 root 3. Okay, similarly substituting the value of that one, and mass kitna liye re bhai, 30 kg. Okay, so can I say that n1 cos of 30 degree is equals to n2 sine of 30 degree plus of mg. Can I write like this? Okay, then substituting the values, then cos 30 is what, root 3 by 2. So n1 root 3 by 2, and which is equals to n2, this is what, nothing but 1 by 2, and plus of mass is 10, that is what, 100. Can I write like this? Substituting the value of n1 here. So n1 can be written as n2 root 3 into root 3 by 2, and which is equals to n2 by 2, that is what, can I say, write 200 directly. लिख सकता हूँ? Okay. Then this become root 3 into root 3, that is 3 n2. So 3 n2, which is equals to n2 plus of 200. Okay, take n2 over here, you will be finding 2 n2. That means n2 is nothing but, can I say, 200 upon 2, that is nothing but 100 Newton. Are yes or no? Substituting the value this over here, you will be getting what? N1. Then N1 is equals to, that is what? 100 root 3. Kitna ko aaya bhai answers? Excellent, very good. Now see, N2 value is having different value, N1 is also having different value. So what I want to tell you that whenever the system is symmetric, then and then only you will be most probably finding the normals equal. Normals are equal. If the system is not symmetric, either in that question or either in this question, you will be finding what? Different values of what? Normal. Have you got my point? Now, write down. Okay, write the heading, next heading, explanation of Newton's first law. Okay, shall I? Now listen to me. Consider here is a surface. On this surface a body is being placed. Let's say this mass is what? M, and the body at this point is at rest. Body is at rest. That means, can I say velocity is equals to what? 0. Can I? Okay. Now let us say how many forces are acting initially. Definitely one force, that is what? mg in the downward direction, obviously, which is equal in and opposite in direction, that is what? Normal. 2 forces are acting. Yes or no? Okay. Similarly, consider I added one more force in this direction, and I said this one is F1. Force F1, whatever the amount is. Okay. Similarly, I added one more force over here in this direction, let's say F2. How many forces are acting right now? 4 forces. Similarly, consider one more force is acting in this direction, and let's say it is making an angle of theta 1. Then can I resolve over here? Then this force will be going in this direction. Yes or no? Then can I say this is also theta 1? Then in this direction. That means in this direction like this. Can I say, let's say this is F3 of cos theta 1, and in the downward direction this force is having the component F3 of sin theta 1. Yes or no? Okay. Similarly, one more force is acting in this direction. Let's say this is your F4, and consider it is making an angle theta 2. Then can I say that one force is acting in the downward direction and one force will be acting in this direction? Yes. Then can I say that this will be F4, cos theta 2, and this one will be F4 sin theta 2. Yes or no? So n number of forces are acting both in x-axis, both in y-axis, in positive coordinate as well as in negative coordinate. Hoga ke nahi hoga? Those are acting in the downward direction should be taken as negative. Those who are acting in the upward direction taken as what? Positive. Yes or no? And those who are moving in this direction, the force which is applied in this direction is considered as what? Positive, and in this direction considered as what? Negative. We all know this. What I want to tell you that if net force means vector sum of all forces. Vector sum of all forces is called as what? F net. It is represented like this, F net. Okay, so total how many number of forces are acting along x-axis as well as along y-axis if their sum is equal to 0. That means if F net is 0, then right now can I say that body will still remains at rest? Yes or no? देखो इधर से 10 Newton लगाए, इधर से 10 Newton लगाए. mg is acting in this direction 10, let's say normal is also acting in the upward direction, that is what? 10. I applied over here, let's say 10 with an angle 37, you will be finding this value, and let's say F4 is also 10, again I am applying with the same angle 37 degree. All values will be getting cancelled out now. Are yes or no? So what I want to say is, if the total vector sum of all forces acting on the body, that is nothing but F net, is 0, then body will still remains at rest. Body will remains at what? Rest. And whenever you will be finding F net is equals to 0, then the body is at static equilibrium. इसको क्या बोलेंगे state को? Static equilibrium. Why we are calling this as static equilibrium? Because the body is at rest. So rest, we know that it is also called as static. So body is at equilibrium. So can I say that if F net, the net total number of forces are acting on the body, that is what F net is equals to 0. If a body is at rest, remains at rest, and what we are calling that static equilibrium. Yes or no? Similarly, consider one more body is in motion. Consider having a mass m, and this body is initially moving with some velocity v. With some velocity what? V. And similarly, I added n number of forces here, from here, normal, mg, all forces are acting. Still, if F net is 0, if the body is in motion, continues in motion. If the body is in what? Motion, continues in motion. Okay? And here, then we call this state as dynamic इक्विलिब्रियम. क्या बोलेंगे उसको? डायनामिक इक्विलिब्रियम. Over here, body is in motion. That is the reason we are calling this as dynamic equation. What is happening in reality? Velocity here remains what? Constant. If velocity is constant, then acceleration is what? 0. So what I want to tell you that whenever you will be finding on a system F net is equals to 0, then there are only two cases are possible. Either the body will remain at rest, or either the body is in motion, and then the body will be moving, that to be with constant velocity. Constant velocity means neither the direction should be changing, neither the magnitude should be changing. Yes or no? Why? Because vector velocity is what? A vector quantity. Either the direction also changes, you will be finding acceleration. So what I want to say is, whenever you will be finding F net is equals to 0 on a system, either the body will remain at rest, or either the body will remain with what? Constant velocity. And whenever the velocity is constant, acceleration is what? 0. If acceleration is 0, then body is not moving in any random direction. Body is moving in, can I say, straight line path. Straight line path. So can I say that this is nothing but the explanation of Newton's first law? So what we are going to learn over here, F net should be the correct statement, or F external is only enough. F net is the correct statement. So one more time, if a body is at rest, remains at rest, and if a body is in motion, continues in motion, unless and until net external force acts on it. ठीक है, अभी मेरे को इसको चेंज करना है, velocity. Other than these forces, I have to apply one more external force on this body to change the state. So whenever we are writing the Newton's law, remember that is what? F net. If F net is not equal to 0, if F net is not equal to what? If F net is not equal to 0, then can I say that it will be stated under second law. तो वो क्या हो जाएगा? Newton's second law. Explain yourself, we will discuss Newton's second law also. Okay, so whenever you will be finding what? F net is equals to 0, then the body is at rest, or either it is moving with what? Constant velocity. Obviously it is following what? Newton's first law. If F net is not equal to 0, that means all forces are being cancelled, only maybe one or two are left out. Then can I say, for example, like this, consider over here, this one is mg and this one is your normal. Let's say I applied in this direction 10 Newton, and in this direction I applied one more force in this 10 Newton, and one more I added in this direction, let's say 10 more Newton. F net is 0 now? No. F net, this force 10 Newton and this force 10 Newton, this normal, this mg will cancel out each other. Only thing what left out is what? This 10 Newton. Okay, so this 10 Newton is moving. Now whenever you will be finding this statement F net is equals to not equal to 0, that means F net is not equal to 0, then and then only you will be finding acceleration is also not equal to 0. Acceleration is also not equal to 0. Now let us try to understand this by statement of the second law. What Newton says in the second law? The rate of change of momentum is directly proportional to the amount of force what we have applied. That means, can I say that it is again talking about F net? So F net is equals to d momentum upon dt. ऐसा लिख सकता हूं. Momentum is nothing but P is nothing but what? mv. P is nothing but mv. Now how we are getting one equation, that is what always we have remembering this F is equals to ma na. ये कब अप्लाई होगा? Let us try to understand this also. So according to the Newton's second law, F net is equals to rate of change of momentum with respect to time, and momentum is nothing but what? mv. So can I say that F net is nothing but dmv upon dt. dmv upon dt. Now try to understand this. इसको ऐसे लिख देता हूं पहले. So F net is equals to, can I write this as m dv upon dt plus of v dm upon dt. Can I? In this one, can I say velocity is changing? And in this one, can I say mass is changing? Yes or no? Now tell me, is it possible to have change in mass? Yes. Yes. Consider a truck is going, and in that truck there is a container is been fitted, and in that container consider water is been filled. Okay, उसका वॉल खोल दो, वो गाड़ी जा रही है. Yes or no? उसका पानी रोड पे गिरेगा कंटिन्यूसली. अरे yes or no? Consider you are having a container on the truck, and continuously, let's say the water is having a weight of consider the mass of water is let's say 100 kg. I am talking about mass, not liters. Okay, the total mass of the water inside this container is what? 100 kg. Consider water is being continuously leaking out, and this body is moving in this direction. Can I say that after some time the whole water is being leaked out on the ground? Yes. Now before and after, can I say there will be a change in mass of 100 kg? Yes. So mass can be changing. Yes, mass is also changing when a body is in motion. Similarly, we can also understand this by rocket. When rocket is being launched in the upward direction, from the propellers continuously fuel is being burnt out. Yes or no? So whenever the fuel is burning out, then can I say that mass of the rocket is getting decreased when it is moving in the upward direction? Yes. So whenever we are discussing about change in mass, हम आगे पढ़ेंगे change in mass, but at now we will be considering mass is equals to constant. If mass is constant, we will discuss that change in mass questions also. Okay, वो आगे पढ़ेंगे. अभी के केस में क्या पढ़ेंगे? The correct formula should be F net is equals to m dv by dt plus of v dm upon dt. This is the correct statement of the Newton's second law. Okay, and what we are saying, if we are considering mass as the constant, then and then only we are writing that F net is equals to m dv upon dt, and we are considering this whole system should be equal to what? 0. Okay, if that whole system becomes 0, then and then only dv upon dt is nothing but ma. ये है करेक्ट फॉर्मूला, एंड दिस इज एफ नेट. इट इज नॉट ओनली एफ. ओके, अभी इस सिस्टम पे मैं इधर से 30 न्यूटन का फोर्स लगा दूं. ओके, देन कैन आई से दैट 10 न्यूटन इज एक्टिंग इन दिस डायरेक्शन, 30 न्यूटन इज एक्टिंग इन दिस डायरेक्शन, रिमेनिंग ऑल अदर आर बीइंग कैंसल्ड आउट. Left out is what? This 10 Newton and this what? 30 Newton. The difference in these two, that is what? 30 and this 10. Can I say minus of 20 Newton? Yes or no? अबे 10 इधर जा रहा है पॉजिटिव, तो प्लस आएगा, माइनस दैट वन. ओके, सो व्हाट आई वांट टू से इज whenever we are writing the force, this force is not only that the force. You should be writing F net. How many forces are acting along the x-axis, or either the body is moving in x-axis, and how many forces are acting on the y-axis if the body is moving along the y-axis. याद रहेगा ये बातें. So this is the correct equation if mass should be taken as what? Constant. There is no change in the mass, then and then only we can apply F net is equals to what? ma. If mass is changing, you should be using this statement. Okay, we will learn how we are applying this statement in a correct order. Okay, till now, note down this. Okay, shall we? So right on the next heading, that is what tension. इसके बारे में थोड़ा पढ़ते हैं and let us try to understand this. Tension. So whenever we are discussing about the word tension, tension is also a kind of force. Definitely it will be having its component and as well as directions. Okay, now if we are discussing about the tension, definitely we are discussing about the word string. String. Acha, when normal is applicable? Normal is only applicable when there are two contact surfaces are available. Yes or no? Similarly, tension is only applicable if the string is what? Tight. So if a string is tight, if a string is what? Tight, then and then only you will be finding what? Tension. And if a string is not tight enough, then we should not consider tension at all. Then there will be no tension. Okay. Now, similarly, if we are discussing about the string, consider this is your string. Okay. Now, in this chapter, you will be finding two types of string. One, that is what this string is having mass, and the other is what this string do not have any mass. That means, can I say that string you will be having what? One is what? With mass, and the other is what? Massless string. सबसे पहले डिस्कस करते हैं massless string. Okay, if the string is what? Massless. If string is what? Massless, then we are describing some properties of this string, and that is what? The second property, that is what? Inextensible. Inextensible का मतलब है non-stretchable. Non-stretchable. That means we cannot stretch this string. Even though in real life there will be some stretching. There will be some stretching. For example, this there is a rope. Consider there is a rope, and we are considering that it is made up of massless material. Okay, and whenever we are discussing about massless string, we consider that it is stretching, but in comparative to 1000 meter, 1 meter is being neglected. Na same thing. It is what? Inextensible. That is what? Non-stretchable, and the second property is what? Massless. Okay, and tension is only applicable if string is what? Tight. Similarly, let us move ahead. For example, if we are saying that this string is non-stretchable, that means if I mark a point like this on string A and over here as B, if it is non-stretchable, then can I say that the distance between A and B, that is what? DAB is, can I say, always remains what? Constant. Are yes or no? So the distance is unchanged. Where we are discussing this? This we are discussing for massless string. In massless string, it is non-stretchable, massless, but breakable. उसके भी questions आएंगे breakable के. But what we are discussing that if I mark 2 points on the string, then the distance between these two are unchanged. Okay. Similarly, if this is the string, then can I say that this is the point A and this is the point B now? Yes or no? Can I say that if distance is constant, where the distance is constant? Along the string now. If distance is constant along the string, then can I say that velocity of points, that is what A and B, are all same. Okay, where? Along the string. Along the string. Similarly, we know that tension is what? A vector quantity. Why? Because tension is nothing but a force. Can I also say that, consider like this? Here is the point A, and this point A is moving in this direction with v1 velocity, and point B, here consider this is the point B, and this point B is moving in this direction with v2 velocity. Okay, point B is moving in this direction and point A is moving in this direction. Let's say this is making an angle theta 1, and consider this is making an angle theta 2. Theta 2, then can I say that along this component, that is what? This becomes v1 of cos theta 1, and over here this is what v1 sine of theta 1. Similarly over here and over here that is what v2 cos of theta 2. over here v2 sine of theta 2. कौन से component equal होंगे? Yes, cos वाला. So v1 cos theta 1 and v2 cos theta 2 will be equal. v1 cos theta 1 is equals to v2 cos theta 2. Always depends on the theta mentioned. Okay. So can I say that v1 and v2, these are the velocity along, again, velocity along the string. These are the velocities along the string. So the basic properties of what? The massless string. Massless string, it is non-stretchable. If they are non-stretchable, definitely the distance between points, any 2 points, is what? Always remains constant. If distance between any 2 points are what? Constant, then can I say that velocity along the string are always same. Those 2 points will have the same velocities. Are yes or no? If they are moving in different directions, if they are moving even though in different directions, those 2 points will be having same velocity along the string. Are yes or no? I read on these properties. Okay, shall I? Now let us try to understand how to mention the direction of what? Tension. Consider there is a fixed point over here, mass m. Mass is what? M. Now mg is acting in the downward direction. Yes or no? Where will be the tension acting? Upward direction. Okay. Now how many point of contacts are there on the string? Can I say 2? Can I say this is the point of contact first, and can I also say that this is your point of contact? Okay. If we are writing, consider you are sitting here. So can I say this is the point of contact? So direction of tension is always away from the point of contact. ऐसा याद रखो. Direction of tension is always away from point of contact. Okay, now listen to me. This is the point of contact. That means you are standing here. If you are standing here, away का direction किधर होगा? ऊपर होगा नीचे? ऊपर. That means this is the direction away when seen from here. Okay. Similarly, consider you are sitting here. What will be the away direction? This is also the point of contact, na? So this is also the direction of what? Tension. This is the direction of what? Tension. अरे आया के बात समझ में? So direction of tension is always away from the point of contact. But let us try to understand further ahead in this only. Consider this is the mass m. mg is acting in the downward direction. And we are saying that if we are writing from the body case, if we are writing FBD for the body, then definitely tension will be acting in the upward direction. Are yes or no? Okay. Now consider who is acting or who is applying this tension and who is applying this mg. Normal का case में याद करो. This is the surface. Surface is applying the force in the downward direction. Earth is applying the force in the upward direction, that we call what? Normal. Are yes or no? So the bottom mass is applying force on the block, that is being mentioned as normal. Similarly, this block is applying force on this body, the heavier mass, that is what Earth, that is what mg. ऐसे ही पढ़े. Similarly, can I say that this mg is the force which is applied by the string? Mg is the force applied by the string, and tension is the force which is applied by this mass. आया क्या? Similarly, उसको जैसा पढ़े इसको भी वैसे ही पढ़ना है. Okay, so who is applying this mg? Block. Are you sure? अब बीच बोला tension string. हाँ. So who is applying this mg? String is applying what? Force on block in the downward direction, and tension is the force which is applied by the block in the upward direction. अरे yes or no? अच्छा, if we are saying that it is applying the force in the upward direction, तो ये string को छोटा कर रहा है या बड़ा कर रहा है? छोटा कर रहा है. So can I say that the direction of tension is always trying to compress the string? देख लो, इसमें भी देख लो. This is the point of contact. Yes, this is also the point of contact where this tension is being directed towards each other. Now that means it is trying to compress the string or increase the string. Compress the string. So direction of tension is always along the direction. What क्या बोलो इसको? Direction of tension is always tries to compress the string. Okay, direction of tension is trying to compress the string, and always you should be moving away from the point of contact. Who is applying the tension? Block is applying the tension. Who is applying the mg? String is applying the mg. I got my point? Right on. थोड़ा सा सुन लो. हो गया बेटा, 10-15 मिनट में भेज दूंगा. Only last 10 minutes, please. So let's say like this. Here is a surface. This one is 2 blocks are there like this, and some force is applied in this direction, and string is being tied on this. This is considered block 1. This is your block 2, and consider the whole system is accelerating in this direction. Okay, इसको खींचो. Force is applied. So when the force is being applied on this, definitely this one will be having a mass m1 and this one will be having a mass m2, and the string get tight enough, and if we are sitting on this block, then tension will be always away from the point of contact. Where is the point of contact? This is the point of contact. That means for this one, can I say tension is acting T1? Yes. Okay. Similarly, if one more person is sitting over here, then he will be saying that this is the point of contact, then direction of tension is over here. Now in massless string, especially remember this, in massless string we are discussing again about what? Massless string. Then if we apply the tension, abhi tension ko dekho, string, so T2 is acting in this direction and T1 is acting in this direction. Yes or no? T2 and T1 both are forces. Yes or no? This string is accelerating in this direction. Are yes or no? This string has mass is equals to how much? 0. Are yes or no? Then can I say that if F net is equals to ma, then T2 minus of T1 is equals to ma, mass is 0, then whole system becomes 0. Then can I say that T2 is equals to T1? T2 is equals to T1. That's the reason in many books you will be finding that in a massless string, tension at any point is what? Same. So for massless string, ये applicable है सिर्फ massless string के लिए. So in massless string, tension at any point is same. Okay? Tension at any point in the massless string is same, but these things are not applicable for what? Mass string. Mass string की बात करें with mass, जिसका mass 0 नहीं है. Okay, over here you will be finding velocity of points, velocity of 2, 3, whatever the points are, velocity of different points, and will be having different velocities. ऐसे लिख लो, velocity of different points, velocity of different points or different इसकी तो different points ऐसे लिखो, different points will have different points will have different velocities. Definitely if velocities are different, definitely there will be having a different acceleration, and tension is also different. So in mass string where the mass is not equal to 0, always remember that the points will be having different velocities, different acceleration, as well as different tension. But these things are not applicable for what? Massless string. In massless string, velocities along the string is constant. That means same. Distance never changes between 2 points. Why? Because it is non-stretchable. Are yes or no? Similarly, the tension at any point is same. In what? Massless string. These are the basic properties of what? Tension force. And when the tension is applicable? When the string is what? Tight or taut. Okay? Likh. Shall I? Okay. I will draw two different diagrams now. You have to tell me the values of tension in both cases. Okay. Consider this is the first diagram. And one block is being attached. Let's say this having a 10 kg mass. And similarly, one more block is being attached over here. This one is having 20 kg mass. Okay, again string is what? Massless. ठीक है, मैं बता दूंगा किसमें mass होगा. Okay, unless I say this one is having a mass, you have to consider string is what? Massless. Similarly, consider the same one like this. One more diagram, and this is one single string, and on this single string, one bird is sitting here. Okay. And this bird is also having a mass 10 kg ले लो इसका भी. Similarly, one more bird is sitting here like this. हाँ, bird ही दिख रही है वो. ले. Two birds and this bird is having a mass 20 kg. Tell me the difference between these two cases. पहले try करो, tension निकालो. Okay, how many of you says tension will be different? Just raise the hand. Okay, how many of you says tension will be same? In this and in this, tension will be same. Tension will be different. Okay, let us try to understand this. पहले ये mg बताओ. इस केस में देखो, इतना देखो सिर्फ. Just see this, the bottom portion. Okay, what will be the mg acting on this block? 200 Newton. So can I say 200 Newton is acting in the downward direction? Yes or no? Let's say T1 is acting in the upward direction. Yes or no? So can I say that T1 is nothing but 200 Newton? लिख सकता हूँ ऐसे? Yes or no? Okay. Now forget about this. Now see the upper portion. First block. Okay. Now you are sitting here. If you are sitting here, how many point of contacts are there? 2 point of contact. So this is your first point of contact. This is your second point of contact. Now tell me mg is acting for this block. किधर ऊपर लगेगा नीचे? नीचे ही लगेगा. So mg is acting in the downward direction. Are yes or no? And the value will be definitely, that is what? 100 Newton. Are yes or no? Okay. Now this is the point of contact. Tension direction is always away from here. That means away from here means you have to check in this direction. Nah. Are yes or no? So from here to here, string is 1 or 2? 1. That means what you have got? T1. T1 is equals to how much? 200. That means in the downward direction is also T1 and that value will be 200 Newton. Are yes or no? Just now we have learned one property that tension at any point on the string is what? Same. That means if 200 Newton is acting in the upward direction, definitely if you are measuring from here, that means from this point of contact, tension is acting in the downward direction, definitely it will be having the same magnitude, that is what? 200 Newton. Now tell me, because of this block, what will be the direction of tension? Now other point of contact is here. So from in the upward direction. So can I say this is the direction of T2? Are yes or no? Now substituting the value over here, then can I write how many forces are acting on this block in the downward direction? 2. That is what? T1 and mg. So can I say that T2 is nothing but T1 plus of mg, and T1 we don't know. Sorry, T1 is 200. 200 plus of this 100, that is what? T2 is equals to 300 Newtons. आया? अच्छा, तुमको ये आंसर नहीं आया T2 का? ओके, अभी तो समझ में आ गया ना क्या करना है. सो ऑलवेज रिमेंबर, स्टार्ट फ्रॉम हियर. ऐसा जरूरी नहीं है कि इधर से स्टार्ट करें. Once you make a practice, you will understand, you can do the answers. So over here 20 kg is the body. Definitely we know that mg is acting in the downward direction and tension is acting on this. Why? Because there is only one point of contact, definitely away from each. This point means in the upward direction. Yes or no? When we are sitting on this block, we found that there are 2 points of contact of the string. One is going in the downward direction, the other is going in the upward direction. Are yes or no? And in the downward direction, this is the same string what we have used in the upward direction. Yes, that's the reason we know that tension at all points on the string of massless string are same. Okay. Now, from here, this is the point of contact in the upward direction. So, this is the FBD and we are resolving the forces here. Yes or no? Okay. Now, let us come back to this situation. Let us start with this. So, this bird is having a mass of how much? 20 kg. Definitely, this bird will be providing mg in the downward direction. That is what? 200 Newton. Are yes or no? Yes. So, can I say that if I am sitting on the bird, then I will be saying that there will be a point of contact in the upward direction. So the tension is moving in the upward direction. So let's say इसका नाम दे देंगे T1. Okay. So T1 is acting in the upward direction if I am measuring from this point. Okay. So mg is acting in the downward direction. T1 is acting in the upward direction. Again, I can say that T1 is equals to 200 Newton. So from here where the bird is holding their leg to the other bird where this bird is holding the leg, that means from here to here tension is same, that is what T1. कहाँ से कहाँ तक? इस point से लेके इस point तक. अरे yes or no? Okay. Do this bird has her own weight, that is mass, that is what 10 kg, and that definitely this bird will be applying, that is mg, that is what, how much? 10 kg, that means what? 100 Newton. Are yes or no? So if I am sitting on this point where the girl is where the bird is holding the legs, then can I say that this away from the direction means this is the direction of what? Again, can I say T1? Why? Because we know that from the point of contact to the point of contact, string is same. That means from here to here, tension will remain how much? 200 Newtons. Are yes or no? Now there is another point of contact, that is what? Moving in the upward direction. This is the direction of what? T2. Are yes or no? So again, mg and T1 is acting in the downward direction. T2 is acting in the upward direction. Writing the equation for force, T2 is equals to T1 plus of mg. Then can I say T1 200 Newton plus of mg, that is what? 100, that is nothing but 300 Newton. So जब भी कोई string दिखे तुमको, if there are n number of masses are being attached in this line form, एक ही line में ऐसे masses दिख रहे, और you will be finding n number of birds, monkey, human being, कुछ भी दे दो example में, single string के साथ रहेगा, तो tension for every point will be different. It won't have the same tension. Always remember this. Okay? आगे बात समझ में? Note down. Consider, you have to tell me the answer fast. जितना जल्दी बोले उतना जल्दी घर भागो. Consider here is one string tied over here on a block, and this string is moving over here. This one is having 10 kg. Answer बताओ जल्दी. Find the tension. The value over here T1 and T2 both will be same, both will be different. It depends on you. Similarly, the next question is like this, and consider over here. ले लो ऐसे ही ले लो. This mass is 10 kg and one more is tied like this. Okay, this one is over here. ये T1 इसमें है, T2 इसमें है. Okay, similarly one more question बना देता हूँ जल्दी से. ऐसे बनाओ. T1, T2 and तुम आंसर करना स्टार्ट कर दो बे. This one theta1, this one is theta2. Here given that theta1 is equals to theta2. Mass is 10 kg. Mass is 10 kg. Mass is 10 kg. If this one is making an angle, let's say 37 degree, and इसको भी ले लो angle के साथ ले लो. Sorry, this one is making an angle, let's say 37 degree. This is also making 37 degree. जल्दी बोलो आंसर और घर भागो. Okay, very good. So for this T1, can I say this T1 and this one is 37. Definitely this one is what? T1 of cos of 37, and this one is the T1 sine of 37, and similarly you will be writing the T2 sine of 37 degree. Over here you will be writing what? T1 cos 37 degree. Yes or no? This and this will be cancel out. Why? Because the whole system is what? Again symmetric. देखो इधर भी 37 है, इधर भी 37 है. Those who have done this, excellent answer. Then T2, that means 2 times of T1 cos of 37 is equals to mg, and mass is given 10 kg. Then T1 and इसको ऐसे लिख दो, 2 into T1 cos 37 is what? 4 by 5, which is equals to mg, that is what? 100 and 1s 50s 4 ones, वो जो भी आ रहा तुम सॉल्व कर लो बे. So this is 4, that is what? T1 is equals to 250 upon 4 newtons. आया सभी का? Very good. Similarly over here, can I say that always away from the point of contact na? So this is the direction of tension from this point, and this point, this is the direction of T2. Are yes or no? Okay. Then can I say that if this is 37, then this obviously becomes 97. This becomes what? 53 degree. Are yes or no? Then can I say that one component is acting in this direction, tension, one component is acting in this direction. Are yes or no? Similarly, mg is acting on this body in the downward direction. Then can I say that this is nothing but, ऐसे ले लो, T1 इसको 37 लिख लो, चाहिए तो इसको 53 लिख लो, your wish. So T1 cos 37, this is what? T2 na, T2, and this is also T2 cos sine of 37 degree. Your wish, 53 ले लो, 37 ले लो, कुछ भी ले लो. Then from this equation, can I say that T1 is equals to T2 sine of 37 degree, and the other equation can be written as T2 cos of 37 degree, and this is equals to what? 100. Yes, आगे ये भी? Very good, very good. Then can I write T2 is equals to cos 37 is 4 by 5. That means can I say 500 upon 4 Newton. Substitute here, तुमको T1 भी मिल जाएगा. Okay. Then similarly come to the last question. And given that T1 is equals to T2, definitely this one will be having the mass, and it is a symmetric option again. Then can I say mg is acting in the downward direction? One component is in this direction, the other component in this direction, both will be cancelled out. Yes or no? Left out is what? This theta values. So can I say that in this one, 2 times of T1, T2 कुछ भी ले लो, both will be having the same value, T cos of theta, and theta both are equal, which is equals to 100. And T is nothing but 100 upon 2 cos theta. Theta की वैल्यू कुछ भी रखो, you will be getting the answer. That is what? 50 upon cos theta. हो गया? टेंशन भी खत्म, टॉपिक भी खत्म, जाओ घर.